last example in 1.2, this is example 4. These are harder. You're going to see a lot of these as we go through the course. Getting the transformed equation is going to be really important and definitely a bit of a tricky concept. Right away, though, I want to make sure you understand what we're really doing here. We want to describe g of x as a times f of bx. Now, some of these might be trivial, and when I say trivial, is that if a is equal to positive 1, there's no effect, because multiplying by positive 1 does nothing. And if b is equal to positive 1, there's no effect. And I think that's really important, that because a and b are ultimately coefficients, they might not be written. In fact, they're not going to be written if they're 1. If we look at y equals f of x, even though they're not written, we could say that that's y equals 1 times the function evaluated at 1 times x. But that's just ridiculous to write, so we typically don't do that. Now, there's basically two ways of doing these questions, two ways of doing A, and that's going to be something that we focus on later in the course, is that often we can achieve the same end result through a vertical stretch or a horizontal stretch. And it really does depend on what you're comfortable with. I like doing a vertical stretch kind of when possible, just because it's applied to the outside of the function. It's a little bit easier. So looking at f of x, I can identify that one of my coordinates on the original is 4, 4. Watch that scale. It is 2 per tick. And then this is turning into the point on g of x. I'm going to draw that dotted line, that is going to become 4, 12. Now I'm going to do this as a vertical stretch first. So in order to go from 4, 4 to 4, 12, 4 multiplied by 3 is equal to 12. That means that there is a vertical stretch by 3, which tells me that my a parameter is 3. So that's it. We can now say that function g of x is 3 times function f of x. Now, we know f of x. It's told to us in the question, so that means that we could give g of x as 3 times the absolute value of x. Okay, I'm going to do B in a second here. I want to talk about kind of an alternative way of doing part A, which is a horizontal stretch. Now, I'm just going to get rid of the marking that I did on the board itself, but really importantly, I'm going to look at a different point. And the reason that I have to look at a different point is if I look at 4, 4, if I did just a horizontal stretch, that's going to turn into this point. I don't know where that point is. It's not a nice intersection. So instead, what I'm going to do is I'm going to look at this point right here. Let me get rid of the point that I marked up so it's not confusing. And we're going to talk about how that point, which is at 6, 6, is going to turn into that point right there, which is at 2, 6. Now, importantly, because we're doing this as a horizontal stretch, we see that the y value hasn't changed, and that's okay. So in order to go from 6 to 2, there is a horizontal stretch by 1/3. This is the problem with horizontal. If it's a horizontal stretch by 1/3, then the b parameter is 3. And that is a tricky part for a lot of students. Remember that horizontal stretch is by 1 over, if there's no reflections, it's just 1 over b, but 1 over the absolute value of b is a good general kind of universal statement. We have to make sure we understand that reciprocal nature between the horizontal stretch and the b parameter. Now, if b is equal to 3, then what I can say is that g of x is equal to function f evaluated at bx, or 3x in this situation. And again, we know what f of x is, so I would say that g of x is equal to the absolute value of 3x. Now, those two do not look the same. But the reason that they are is because the absolute value of 3 is 3. So they end up being exactly the same function. And if you graph both of those into your calculator, you would see precisely the same thing. That's a pretty important kind of maybe skill set that we have to develop, is being able to do these questions with a horizontal or vertical stretch. And if you're comfortable with both, then typically you get to pick the easier one for that question. Okay, I'm going to steal that other one as well. I'll just do it on a different page here. When we work with full graphs versus discrete shapes, it can be a little bit trickier. This goes on forever. I'm just going to kind of go over it a little bit heavier, that this is my original function. And typically students do not struggle with the concept that in order to go from the blue graph to the red graph, I can't just horizontally stretch by a number, because those positive numbers are going to stay positive. But if I picture a green reflection line, then I think it's a little bit more clear to see that the red graph is the blue graph reflected over the x-axis. Now, I'm going to write that out, that g of x is f of x reflected, I'll spell reflected right, preferably, reflected over the x-axis. And this is unfortunately part of the memorization required for function transformations, is that we have to know if we are reflecting over the x-axis, then my a parameter is -1, which means that g of x is equal to -1 times f of x. And because we know f of x, we're going to write that as -1 times the absolute value of x. That is not necessarily an exception, but there is no other way of describing that transformation. It has to be a reflection across that x-axis. Students always struggle, or not always, typically struggle with that because we're reflecting over the x-axis, we are multiplying the outside of the function by -1. And it is one of those things that I would recommend that, you know, the best way to truly understand it is to graph this and put these into your calculator. As you're putting them into your calculator, it can really help to use your y equals. And if you have a color calculator, you can make these different line colors. If you don't have a color calculator, you can make them different line shapes. That's a good way of making sure you know exactly what your calculator is graphing at the time. All right, that is it for 1.2. Please do the textbook assignment. I know it looks like it's split into two. That's typically just because we talk about reflections and stretches separately. We did it all together in this 1.2 section. So please do try to do kind of all at once because they're really not that different. It's just that when we stretch by a negative number, we describe that separately as a reflection as well. And I think that's worth just writing quickly and taking the last couple minutes of your time here, is that if I had y equals -2 times f of x, I would want to say that this is a vertical stretch by 2, and distinctly or separately say that it is also a reflection across the x-axis. Right? It's really important that if you are asked to describe this in words, we expect you to split those and not just say a vertical stretch by -2.